Hello everyone, this is Katisha. In this video, I'm going to go through the AQA Chemistry Paper 1 Higher Tier from 2022. Question number 8 is on the topic of chemical changes, mainly to do with acids and alkalis and titration calculations. This question is about acids and alkalis. Explain why the pH of an acid depends on the strength of the acid. Now, when we talk about the strength of acids, let's look at some acids before we go forward. So HCl, H2SO4, let me just use two different acids. Hydrochloric acid breaks into H plus and Cl minus ions. Sulfuric acid, there's two hydrogens, so it's 2H plus and 1SO4 minus 2 minus ions. Now, the acidity depends on that, the H plus ions. So sulfuric acid is a stronger acid than hydrochloric acid. So you can see what they mean by the strength. The concentration refers to the number of ions. So again, it's referring to the number of H plus ions here, because acidity depends on the availability of H plus ions. So why does the pH depend? Now, the more H plus ions there are, the lower the pH. So here's the answer, general principle. The pH of an acid depends on the H plus ions. So again, let me just change that because that's incorrect. So I need to write it properly. So it will be H plus ion concentration, and the higher the concentration of H plus ions, the lower the pH is the general idea. The strength, the stronger an acid, the greater the ionization, meaning more dissociation, which will actually break down like this in aqueous solution. So the stronger the acid, the lower the pH. Concentration, the higher the concentration of an acid, the more acid or solute in the same volume of solution. So the higher the concentration of the acid, the lower the pH. Question 8.2. A student titrated 25 centimeter cube of hydrochloric acid with 0.1 mole per dm cube of barium hydroxide solution. Table 2 shows the results. Titration number, they've done it 5 times, and the volume, they've recorded it 5 times. The student calculated the volume of barium hydroxide solution to be used in the titration calculation as 23.5 centimeter cube. So they worked out the average. Explain why the student used a volume of 23.5 centimeter cube of barium hydroxide solution in the titration calculation. Now, if you did work out the average for these 5, you would simply add these 5 values up, which will give you 117.95 divided by 5. It should give you 23.59. But they're using 23.5, which is lower. Why is that? Because this is an anomaly. Because you can see 23.45 is appearing twice, 23.55 is appearing twice, 23.9 is about 0.5 centimeter cube more. So they've ignored that value. It's an anomaly. The mean of titration values 2 to 5 values is calculated because 23.9 centimeter cube is an anomalous result. "25 centimeter cube of the hydrochloric acid reacted with 23.5 centimeter cube of the 0.1 mole per dm cube barium hydroxide solution. The equation for the reaction is 2 moles of hydrochloric acid is reacting with 1 mole of barium hydroxide solution to give 1 mole of barium chloride solution and 2 moles of water. calculate the concentration of the hydrochloric acid in mole per dm cube. Now, in terms of reacting moles, 2 moles of HCl is reacting with 1 mole of barium hydroxide in terms of mole ratio. So we are using 23.5 centimeter cube of 0.1 mole per dm cube of barium hydroxide. So let's find the number of moles in that volume of barium hydroxide. So number of moles of barium hydroxide is equal to, so 23.5, that's in centimeter cube. I'm trying to convert it to decimeter cube, so I'll have to divide that by 1000 and then multiply that by 0.1 mole to give 0.00235 moles of barium hydroxide. So the mole ratio is 2:1. So if I have 0.00235 moles of barium hydroxide, I should have double the number of moles of HCl for that. So number of moles of HCl is equal to 0.00235 times 2. That would give me 0.00470 moles of HCl. Now I need to convert that back into the concentration because I'm only using 25 centimeter cube. So 0.00470. So concentration equals, multiply that by 1000 and divide by 25. That will give me 0.188 mole per dm cube. 1.8. Another student titrated sulfuric acid with barium hydroxide solution. The equation for the reaction is 1 mole of sulfuric acid is reacting with 1 mole of barium hydroxide to give 1 mole of barium sulfate and 2 moles of water. The student measured the electrical conductivity of the mixture during the titration. The better conductor, the higher the electrical conductivity value. Figure 10 shows the results. So at the start, when you haven't added any barium hydroxide, electrical conductivity is nearly 2.6. So as you add barium hydroxide, which makes sense, as you add barium hydroxide, the barium sulfate is a solid and is neutralizing to form water. The acid and the alkali is being neutralized by the alkali. So as you add more alkali, the acidity goes down. So electrical conductivity, remember, electrical conductivity depends on the movement of electrons, but also on the movement of ions. So here at the start, we have sulfuric acid, H2SO4, and the H plus ions are able to move initially, but as you add OH minus ions from here, from the alkali, these OH minus ions will react with the H plus ions and remove them from the solution. So explain why the electrical conductivity of the mixture was 0 when the sulfuric acid has just been neutralized. When it's just been neutralized, there's no more H plus ions. So the ions can't, and the barium sulfate is a solid, which is insoluble as well. So here's the answer. There are no ions that are free to move. We are referring to the H plus ions here, because barium sulfate is solid, right, and it's insoluble. The hydrogen ions have reacted with hydroxide ions to produce the water. So you could say all the hydrogen ions. The student then added a further 10 centimeter cube of barium hydroxide solution. The electrical conductivity of the mixture increased. Now, if you add more, then you're introducing more OH minus ions, which will be able to move and conduct electricity. So the mixture now contains barium ions and hydroxide ions that are free to move. Sorry, missed the barium ions in the Ba plus ions. That brings us to the end of question number 8 and to the end of the paper. Thanks for watching. I will see you in the next series of videos.